Have you ever wondered how computers think? It's a fascinating process that happens every time you use your device. They have a brain, just like you and me. But instead of neurons, they use circuits and transistors. It's called the CPU, or Central Processing Unit. This tiny chip is incredibly powerful and essential. The CPU is the boss of the computer. It handles all the instructions it receives from both hardware and software. It tells all the other parts what to do, whether it's opening a file, running a program, or even just moving the mouse cursor. Think of the CPU like the conductor of an orchestra. Just as a conductor ensures harmony among musicians, the conductor tells each musician when to play and how loud to play. The CPU coordinates all the computer's activities. The CPU does the same thing for the computer. It processes data, executes instructions, and manages the flow of information. The CPU makes sure everything runs smoothly. It ensures that tasks are completed efficiently and without errors. Without a CPU, your computer would be lost. It wouldn't be able to perform even the simplest tasks. It wouldn't know what to do. The CPU is truly the brain of the computer, making everything possible. Let's meet the CPU's team. This team is made up of several crucial components, each playing a vital role in the CPU's operation. Think of them as the brain's different parts, each with a unique function that keeps everything running smoothly. First up, we have the control unit. This is the part of the CPU that acts like a conductor in an orchestra, ensuring that every other part knows exactly what to do and when to do it. This is the leader of the pack. It directs the flow of data and instructions within the CPU, making sure everything is in sync and operating efficiently. It fetches instructions from memory and tells the other parts what to do. Without the control unit, the CPU would be like a ship without a captain, lost and directionless. Next, we have the arithmetic logic unit, or ALU. This component is the CPU's math whiz, handling all the calculations and logical operations that the CPU needs to perform. The ALU is a math whiz. It's responsible for performing all the arithmetic operations like addition, subtraction, multiplication, and division, as well as logical operations like comparisons. It performs all the calculations like addition, subtraction, and comparisons. Without the ALU, the CPU wouldn't be able to process any data or perform any tasks. We can't forget about registers. These are small, fast storage locations within the CPU that hold data and instructions temporarily. They are like little storage boxes inside the CPU. Registers are crucial for the CPU's operation because they provide quick access to data and instructions that the CPU is currently working on. They hold the data and instructions that the CPU is currently working on. This allows the CPU to access this information quickly, without having to go back to the main memory every time. Lastly, we have the cache. This is a special type of memory that stores frequently used data, so the CPU can access it quickly. The cache is a special type of memory. It acts as a high-speed intermediary between the CPU and the main memory, reducing the time it takes for the CPU to access data. It stores frequently used data, so the CPU can access it quickly. This helps to speed up the overall performance of the CPU, making it more efficient and responsive. The CPU's main job is to process instructions. Instructions are like recipes. They tell the CPU what to do step by step. These instructions come from the software you use. The CPU reads each instruction carefully. It follows the instructions one by one. The CPU is very fast and efficient. It can process millions of instructions per second. Section 4. The fetch-decode-execute cycle. Like clockwork, the CPU follows a cycle called the fetch-decode-execute cycle. This cycle is fundamental to how a computer operates, ensuring that every task is processed efficiently and accurately. Think of it like baking a cake. Just as you follow a recipe to bake a cake, the CPU follows a set of instructions to perform tasks. Fetch. First, the CPU fetches the recipe from memory. This is like grabbing a recipe card from a box, or opening a recipe book to find the instructions you need. Decode. Then, it reads the recipe and figures out what ingredients and steps are needed. This step is crucial as it translates the instructions into actions that the CPU can perform. Execute. Finally, it gathers the ingredients and follows the recipe to bake the cake. In the same way, the CPU executes the instructions to complete the task. The CPU repeats this cycle for every instruction. Just like baking multiple cakes, the CPU continuously fetches, decodes, and executes instructions to keep everything running smoothly. It's a continuous process that keeps your computer running. Without this cycle, your computer wouldn't be able to perform even the simplest tasks. This seamless operation is what makes modern computing possible. Section 5. Single core versus multi-core. One brain or many. Some CPUs have one core, others have multiple cores. A core is like a mini CPU. A multi-core CPU is like having multiple brains working together. More cores mean more power. A multi-core CPU can handle more tasks at once. This makes your computer faster and more efficient.